Hi everybody, welcome back to another video on Feynman integration. Today we'll be evaluating this integral. That's the integral from 0 to 1 of the sine of natural log x over natural log x with respect to x. We're going to be using two tools today. This tool right here, it's just the complex exponential form of the sine of a. That means that the sine of a is equal to e to the ia minus e to the negative ia all over 2i. Search for the term complex exponential form of sine of x, and you'll get good explanations on why that's true, but that's beyond the scope of this video. And of course, we're going to be using the Leibniz integral rule. So our first step is to rewrite this using our tool. And what you get if you do that is that I is equal to this stuff right here. And then a further rewrite, you get that I is equal to this stuff right here. The next step is a familiar one. We create a function of t, very similar to this right here, simply replacing this I with a t. There you go. That's our function of t right there. I'm not going to be verbally expressing a lot of these steps because it's exhausting. Anyway, we make note of these two facts right here. Of course, if you plug in negative I for t into our function, you'll get 0. And if you plug in I into our function, you get the thing that we want right here. Next step, of course, differentiate with respect to t on both sides. And that gives you this. I'll kind of walk you through it. Then reintegrating with respect to t gives you this. And that's what we're after. We're after a function of t that we can plug that value into to get I. Of course, it won't work right now because we have this constant of integration. So we have to use the fact that if we evaluate this function at the point negative I, we get 0. And that's written right here. We get that 0 is equal to 1 over 2i times the natural log of 1 minus I plus c. Rewriting it a little bit, we split up that natural log. You can see right here I have the complex exponential form of 1 minus I written right underneath this. So because this is the natural log of a product, you can break it up into the sum of two separate natural logs, which I've done right here. Finally, if you solve that for c, you get that c is equal to pi over 8 minus the natural log of 2 over 2i. So now we have our value of c. Plugging in our value of c, we get this right here. Breaking up this natural log of a product into two separate natural logs, we get this right here. So I is equal to this thing right here. These two things will cancel out, giving us a final answer of pi over 4. And I want to make a quick note on a little mistake I made when I first evaluated this integral. The mistake was this. I incorrectly, I was doing it really fast, and I incorrectly wrote that 1 minus I is equal to e to the negative I pi over 4. That's probably a pretty common mistake to make, especially when you're not used to dealing with magnitudes, which a lot of the time in these videos you're not. But the magnitude, but it's important to remember that the complex exponential form of a complex number involves a magnitude and an e to the I angle. So in this case, the magnitude is actually square root of 2. It's not 1. Because if you visualize the point 1 minus I on the complex plane, you'll see that it's 1. So a length of 1, and then another length of 1. And of course, the magnitude is the distance from the origin. So it's a little triangle. It's a right triangle with opposite and adjacent sides both equal to 1. So of course, that hypotenuse would be square root of 2. Anyway, that's why 1 minus I is equal to square root of 2 times e to the negative I pi over 4, not e to the negative I pi over 4. Turns out that making that mistake didn't give me an incorrect answer to the integral. I still got that the answer was pi over 4, and that's easy to see right here. It's because this is square root of 2 times e to the I pi over 4, and this is square root of 2 times e to the negative I pi over 4. So they're just going to cancel out. And that's the reason why that mistake didn't matter, because what I would have ended up with is the natural log of 1 over 2i, which of course is 0, minus the natural log of 1 over 2i, which again, of course, is 0. Anyway, I just wanted to make a quick note on that probably common little mistake. But anyway, the answer is pi over 4, and that's it. Hope you enjoyed that.